Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. And in this augmented lecture in differential equations, we're going to use technology to show that the slope, or to show the slope and direction field for dy dx is equal to sine of x cos of y. And then we're going to graph a solution curve satisfying this initial condition. And the thing you should note here is that you have to use, well, you technically don't have to, but it's really tough not to use technology when doing a problem like this. Now, as far as modern technology, I haven't fiddled around with a lot of different programs to do this. I'm sure there are, but I use a program called WinPlot, and let me just show you that. So here is the website. All you need to do is actually Google WinPlot and you'll find this website. It is not an updated program. It is actually an older program. So just to let you know, that is something that you're going to have to kind of deal with. And let's see here. There's the web address there, math.exeter.edu, and so on and so forth. Anyhow, it's old enough to have worked with Windows 95. Now, when you first open up WinPlot, it'll just come up with this window here with a little tip. I click on Window up above and choose 2 dimensions. Let me get this sized. That's good enough for me. And then what I'm going to do is to graph that differential equation, dy dx is equal to, actually I can't remember what it's equal to, sine of x cos of y. What I do is I go ahead and just go to equation, and we're going to graph a differential equation of the form dy dx. So I'll choose that first option. And sine of x cos of y is what I'm going to type in here. And the other options here you can leave as they are. These are just going to, the lengths of the lineal elements are very short and so on and so forth. And you can increase the number of rows if you want. You can change the color of each lineal element. So let me make them blue just to do that. And the pen width is only there really if you're going to display this on some other screen, but for now that's good enough. And then this is just all the equations you're currently graphing. I'm going to go ahead and close that as well. So that's using technology to graph the direction field for our differential equation dy dx is equal to sine of x cos of y. And now we want to graph a solution curve satisfying y of 0 is equal to negative 5/2. Now, depending on what your instructor wants for a problem like this, you can either graph one by hand or you can use technology. I'm going to do both here. All right, so what you see here is a screenshot of our direction field for the differential equation that dy dx is equal to sine of x cos of y. And now I'm going to go ahead and draw a solution over that goes through the point 0, negative 5/2. So go ahead and do this. 0, negative 5/2 is roughly about here. And you can see that, let me get this in the center of the screen. You can see the path that it's going to follow. It's going to do something like this. Chicken scratching it out, but it'll probably come down here and come back up. Looks like this on both sides. Okay, so that's one way you could do it, or you could use technology to actually do this problem. So let me switch into technology mode here. And using technology, I'm going to go ahead and go to do this, you're going to click on 1, and you're going to do an initial value problem and a dy dx trajectory. Now, again, this is using WinPlot, so if you use a different program, that's hard to say what you're going to do. But when we want to know the solution when x is 0 and y is a negative 5/2, we want to know what the solution looks like going through that. And I will change the color of it as well to match the color that I did, which is red. And maybe I'll make the pen width 2 just so that you can really see it. And let's see, draw. I'll close this out. And you can see that that actually does, let's see if I can scroll this down, that actually does match what I drew on our little thing right here. So very close, right? So that's not bad. All right, so that's using technology to graph solution curves for differential equations, first order differential equations, using WinPlot.